Hello students. In our previous video, we saw examples of tangents in our everyday life and one property of tangent that it is perpendicular to the radius of the circle at a point of contact. Today we will see another property of the tangent. Take a circle and a secant AB that intersects the circle at points C and D. Now take another secant PQ parallel to AB and it cuts the circle at points X and Y. Now let's move both these secants away from each other towards the circumference of the circle. What do you see? Yes, we saw that when we move the secant towards outside, the distance between the 2 points on a circle decreases and they coincide at a single point and thus they become tangents to the circle. Now such tangents are called as parallel tangents. Now students, draw a diameter at the points of these tangents. You see that the point of contact is nothing but the end points of this diameter. Thus, in other words, when any two tangents are passing through the end points of the diameter of the circle, they will become parallel to each other. Again, take a secant AB, and now how many parallel tangents to this secant are possible? That is, how many parallel tangents you can draw? You see that there are only two parallel tangents to a given secant. Thus, remember students, this is a second property of tangent, that there cannot be more than two parallel tangents to a given secant. Now let us prove this property with a theorem. The theorem is the tangents drawn at the ends of a diameter of a circle are parallel. So what is given to us? A circle with center O and diameter PQ. To prove this theorem, we need to construct a tangent AB through point P at one end point of a diameter PQ and other tangent CD through point Q. What we have to prove is tangents AB and CD are parallel to each other. So let us see the proof. Here we know OP is the radius of the circle and AB is the tangent at point P of the diameter PQ. According to theorem, we already know that the tangent at any point of a circle is perpendicular to the radius through the point of contact. Therefore, radius of the circle and tangent at that point are perpendicular to each other. That is, OP is perpendicular to AB. This implies that angle OPA is equal to 90 degree. This is our statement 1. Similarly, we can see radius OQ will be perpendicular to tangent CD at point Q. Therefore, OQ is perpendicular to CD. This implies angle OQD is equal to 90 degree. This is our statement 2. So from statements 1 and 2, we can see both the angles are equal. We also know one more theorem, that if a transversal intersects two lines such that a pair of alternate angles are equal, then these two lines are parallel. Now here in our case, consider AB and CD as two lines and PQ as their transversal. Therefore, angles OPA and angle OQD becomes alternate angles. As they are equal, we can say that tangents AB and CD are parallel to each other. Hence, we have proved that tangents drawn at the endpoints of a diameter are always parallel. In other words, we can also say that diametrically opposite tangents will always be parallel. Now there is one question for you. Can you prove these tangents parallel using another pair of alternate angles? I'll give you a hint. Prove angle OPB and angle OQC equal in a similar way. So try this as a self exercise. Thank you.